Hello everyone, my name is Syed and welcome to the presentation
of Group 19.
So I'll start with 14. In today's era of industrial and commercial revolution, the demand for various size structures like warehouses has surged, and these are commonly designed using portal frames. The team at Visionary Designs has produced a preliminary portal frame structure to the specifications provided by the client, whilst complying with the relevant Australian standards and codes for steel structures. We are provided with a sketch of the portal frame structure as a guide for how the warehouse should look and a list of parameters, such as 20-meter long building with a frame span of 10 meters, building on 400 millimeters thick slab structure, at least 10 windows spaced throughout 2 doors at the front, and a mezzanine floor 4 meters off the ground, at least 32 meters square in size, as well as eave height of 10 meters and a roof pitch of 6 degrees. So this project was completed using Revit by Autodesk. Preliminary structure design was produced according to the specifications provided by the client and complying with the relevant Australian standards and codes for steel structures. First of all, we have columns. Columns used in the portal frame structure were made of steel 45 to 345 and selected for their strength and durability. These were placed at 400 mm and 7000 mm on the base and top level respectively. Next, we have rafters. Rafters used in the structure are universal beam 406 x 140 x 46 UB made of steel 45 to 345. They are spaced at 5000 mm from each other and the span is 8820 mm. Next we go girts. The girts used in the structure are light gauge lip channels girts C100-12 selected for their strength and durability. These were overhanging at a level of 200 mm and are spaced at 200 mm. Next we go purlins. Purlins used in the portal frame are light gauged Z purlins C100-12 which are 9000 mm long. Fascia purlins come in various designs which enhances its usability for a wide range of purposes. These are overhanging at 200 mm, spaced at 2000 mm and spanned at 215 mm. Then we have wall cladding. Wall cladding used in the portal frame structure is basic wall 24 mm thick span deck. Length of each wall along left to right and front to back is 40,304.4 meters and 18,709 meters respectively. The end and intermediate spanning between them are 2070 mm and 2060 mm respectively, overhanging at 200 mm. Then we have our roof. Roof is on the level 3 of the portal frame and it is basic roof 42 mm. Its total area is 805.827 square meters, which is sloped at 6 degrees from the wall, making it almost flat yet inclined enough to keep rainwater and snow off from the top surface. Its end spanning is 2070 mm, whereas intermediate spanning is 2020 mm. Then we have our doors. Two types of doors were used in the portal frame for different range of purposes. First one is overhead rolling door at the height of 2214 mm, while the other door is a single flush door at a headlight of 2134 mm. Then we have our stairs. There is only flight of stairs in this portal frame which has 20 steps. Depth of each step is 20 mm. Base and top offsets are kept at 0 mm at both levels. In summary, Team Visionary Designs has created a structure design and the portal frame structure via Revit and SpaceGas tailored to the client's wishes. The 20 x 10 meters portal frame structure with a 10 meter high eave offers 765.385 square meters of space supported by 24 columns and 30 beams. This design integrates functionality and aesthetics with 10 well-placed windows, 2 entrances and 3 levels. Level 1 has a robust 400 mm floor, while Level 2 covering 62.679 square meters is accessed via 20 steps and boasts a 6 degrees inclined roof for water runoff and a sleek look. The project was covered primary load cases, analyzed structure behavior with detailed diagrams, and specified member and connection designs to ensure safety and performance by designing the 2D and 3D portal frames from SpaceGas. Also explored the potential consequences of changing support conditions from paint to fully fixed, underlining how this modification can impact load distribution and structure response. At last, this presentation represents the commitment to precision and thoroughness in structure design, ensuring that the portal frame meets both aesthetic and safety standards for real-world applications. Thank you for listening.